Okay, so you've built a basic RAG system, but the answers, they just aren't hitting the mark, are they? You're definitely not alone. Getting from a proof of concept to a truly high-quality AI is a huge leap. So today, we're going to dive into the advanced strategies that turn a good RAG pipeline into a great one. Here's the game plan. We'll start by looking at why basic RAG hits a quality ceiling. Then, we'll walk step by step through the key upgrades, starting with preparing your data intelligently, then finding the best information with advanced retrieval and re-ranking, trimming that down to the perfect context, and finally, putting it all together. First up, let's set the stage. The real challenge with any RAG system isn't just about finding information. It's about finding the right information. It's a question I bet a lot of you have asked. You've hooked up your data, you're getting responses back, but they might be kind of irrelevant, a little off, or sometimes just plain wrong. So where's the bottleneck? What's going on? Well, here it is. This is the fundamental rule of RAG. Quality in, quality out. The large language model is only as good as the information you give it. If you feed it garbage context, you're going to get a garbage answer. If the context isn't enough, the model might start making things up, hallucinating. So the big takeaway is this. Every single advanced technique we're about to talk about is all about improving the quality of this context. So let's get to our first set of upgrades, and these happen before a user even types a single question. This is all about building a much better foundation through smarter data prep. Instead of just blindly chopping your documents into fixed-size pieces, we can get way more strategic. For instance, with semantic chunking, we split data along natural breaks, like paragraphs. That keeps related ideas together. We can also add metadata, things like a product ID or a date, to filter our search down before we even look for similarity. We can also index both tiny chunks for specific details and whole documents for the big picture. And here's a really clever trick. You can use an LLM to generate hypothetical questions for each chunk, which helps match how a real person would actually ask a question. Now, this next point might challenge a big assumption. Most tutorials out there are all about vector databases, but you know what? They aren't the only tool in the shed. If your data is highly structured, a good old-fashioned relational database might be way more efficient. And for finding exact keywords or product codes, traditional keyword search is often much, much better. Okay, our data is prepped and ready to go. So the next step is actually finding the best possible information when a user asks something. This is where we get into the really cool stuff, advanced retrieval and re-ranking. So modern search usually kicks off with dense retrieval. This is your classic vector search. It is fantastic at understanding the user's intent, the real meaning behind their words, even if they phrase it totally differently from your documents. But dense retrieval can sometimes struggle with specifics. And that's where its counterpart, sparse retrieval, comes into play. It's a powerful keyword search that is amazing at finding exact matches. We're talking jargon, product IDs, error codes, anything where being precise is absolutely critical. So you can see the trade-off here, right? Dense gets the intent, sparse gets the precision. The real magic happens when you combine them in what's called a hybrid search. And honestly, this combination is pretty much the gold standard for high-quality RAG now because it gives you the best of both worlds. But this awesome power of hybrid search, well, it creates a brand new problem. You get so good at finding potentially relevant documents that you end up with high recall, a huge pile of results. Just dumping all of that into the LLM is a bad idea. It's too much noise, and it can just confuse the model. That's why we need one more step, re-ranking. So after you retrieve your top, say, 50 documents, a re-ranker's job is to score and reorder them, picking out the absolute best ones to send to the LLM. As this table shows, you've got different ways to do this, each with its own trade-off between accuracy, speed, and cost. You could use a simple, fast method, or you could use a much more powerful, but slower and more expensive cross-encoder, which basically uses a whole other model to deeply analyze the query against each document. So the practical advice here is pretty clear. Start simple. Get your system running with a fast re-ranking method. But for a real production system where accuracy is everything, upgrading to a powerful cross-encoder is often the secret to unlocking that next level of quality. We've retrieved our documents, and we've re-ranked them to find the best of the best. But believe it or not, we're still not done. The final stage is all about optimizing that context, and the philosophy here is definitely less is more. Now, check this out. This workflow is a total game changer, and it can boost accuracy by 20 to 40%. It's a high recall to low tokens pattern. You start wide, retrieving maybe 100 documents. Then you re-rank to find the top 10. but even that's often too much. The third step is to compress those 10 down to the absolute essential information, just 3 to 5 chunks worth. Only then do you send it to the LLM. So how do you do that compression? Well, you've got a few really powerful techniques. One is called context distillation, where you actually use another LLM call to create a short, sweet evidence pack. You can also use structured prompting, which forces the model to cite its sources, cutting way down on hallucinations. You can even make multiple LLM calls to have the model summarize or double-check its own work. Okay, we have covered a lot of individual techniques. So let's zoom out for our final section and see how all of this comes together to form a system that's ready for the real world. See, a truly advanced system isn't about picking just one of these techniques. It's about layering them. It starts with hybrid search with metadata filters. It uses a powerful cross-encoder for precision. It might even rewrite the user's query for clarity before searching. Then it distills the context to keep the prompt clean. And the most important part? It's all built on a foundation of continuous testing and evaluation. Now, I know what you're thinking. This all sounds powerful, but it also sounds really complex and probably expensive, with all these steps and multiple LLM calls. In a real-world application, speed and budget matter a lot. So how do you manage that? This represents one of the single biggest optimizations you can make for both cost and speed. Any ideas what this could be? That 78% is the potential cut in your monthly costs from one thing, semantic caching. The idea is simple, but brilliant. If a new user asks a question that's basically the same as one that's been asked before, you just return the old answer from a cache. You get to skip the entire retrieval, re-ranking, and generation pipeline. The impact is just massive, not just on your wallet, but on making responses up to 90% faster. It's a true game changer. And that brings us to our final thought. We just laid out this super sophisticated, multi-stage pipeline. But is it always the right answer? For some use cases, like searching through legal documents or code, a simpler, keyword-first approach might actually be more precise and cheaper. So the ultimate upgrade, then, isn't just about adding more complexity. It's about choosing the right tools for your specific problem.